Welcome to today's video on class 36, which is going to talk about boundedness and extrema. Boundedness, you would use the y coordinates to determine, and you wanted some questions to ask is the graph bounded above or below? What is the boundaries for y in the graph? If the graph is bounded above or below, but not both, then the entire graph is not considered to be bounded. And I'll explain that when we get some examples. For extrema, there's two types. Local extrema, those are the maximum and minimum y values of a certain area of the graph, not necessarily the whole graph. It happens usually at the top or bottom of parabolas. The absolute extrema, those are the maximum or minimum y values over the whole graph. So if you look at number 1 here, the question says, are the graphs bounded above? And the answer to the question here is yes. If you notice, the top part of the graph does not go past y equals 3. So in this case, the graph is bounded above by y equals 3. That is the top. It is not bounded below. The reason why it's not bounded below is if you notice there's arrows that go down. So therefore, it's not bounded because it's going down forever. So it's not bounded below. So therefore, since one part of the graph is not bounded, the entire graph is not bounded. In order for the entire graph to be bounded, it must be bounded both above and below at certain points. So the entire graph is not bounded. Now, are there any local or absolute extrema? Well, in this case, there is an absolute because that is the very top of the graph. So there's an absolute. And in this case, that top part is the maximum. And the maximum value for y is 3, and it occurs at x equals -2. That is the absolute maximum. Looking at number 2, if you notice this arrow goes up, so that means it's not bounded above. But if you notice below down here, it is bounded. It's bounded at the bottom, or we say bounded below, by y equals -5. That's the lowest point of the graph. It doesn't go any lower. Now, the entire graph, though, is not bounded because the top part is not bounded. Now, here you have an absolute maximum at y equals, or sorry, an absolute minimum, because that is the bottom here, at y equals -5. At x equals -3. So the minimum here of -5 occurs at x equals -3. That is an absolute minimum because that is the very lowest point on the graph. There's also a local maximum because, remember, this graph goes on forever, so there is no absolute maximum, but there's a local maximum here at the top of this parabola, and it's a local maximum of 3, and it occurs at x equals 1. That is a local maximum because it's not the maximum part of the graph, it's just the maximum part of this area at the top of the parabola. All right, if you look at the next one, this is bounded above by the line y equals 6, that horizontal asymptote, and it's also bounded below because the very bottom part is y equals -12. Nothing goes any further below. So the entire graph is bounded because it's bounded at the top and the bottom. Now here you have a couple things. You have a local minimum there of -5 at x equals -6. Notice that's not an absolute because that's not the absolute lowest point of the graph. And you have a local maximum of 2 at x equals -3 because that's not the absolute highest point of the graph either. You have an absolute minimum right here at the bottom. That is the lowest point of -12 at x equals 2. There's no absolute maximum because there's no top of the parabola that is at 6. The parabola just goes close to 6, but it doesn't actually touch it. So there's no absolute maximum in this case. So moving on to the next page. So here we put it all together. The first question, as we've asked before, is this a function? And the answer when you do your vertical line test is yes, this is a function. State the domain and range. Well, if you look here, there's an arrow, and then there's no holes or anything, and it continually goes on forever in both directions. So the domain is all real numbers. The range, well, if you notice, the very bottom of the graph is here at -7, but then it goes up forever. So the bottom is -7, and then it goes on forever. So it's greater than or equal to -7. Where is the graph continuous? Well, you notice you could take your pencil and go through the whole graph without lifting it up, so therefore it's continuous everywhere. Which means if it's continuous everywhere, there is no discontinuity. As far as increasing, decreasing, or constant goes, it is not constant. Increasing, well, if you notice, it increases here. Well, basically, just start from left to right. It decreases from -infinity to -2. It increases from -2 to 0. From 0 to 3, it decreases again. And from 3 to infinity, it increases. Is the graph bounded? The answer to that question is that it is not bounded above. Because notice there's arrows, that means it goes on forever up. However, it is bounded below, and it's bounded below at y equals -7. Therefore, the entire graph is not bounded, because there is one part of it that goes on forever. There are local minimum, or there is a local minimum, and that is right here of -1 at x equals -2, because that's a local minimum. It's not the minimum for the whole graph. There is a local maximum, and that is right here at 1, and that's at x equals 0. And there's an absolute minimum, and that absolute minimum is -7, and it occurs at x equals 3. All right, to the next page. So looking at this one, is it a function? Doing the vertical line test, you will find that it is a function. Even though right here it looks like there's two x's, but notice there's an open circle there and a closed circle, so that only counts as 1 point. The domain, well, if you notice going from left to right, it is all real numbers, because even though there's a circle here, that dot fills it in and it keeps going, so the domain is all real numbers. The range, The range here, if you look at this arrow means it goes down forever. So the bottom goes on forever. And also this means it goes on forever in the top. Yes, there is a gap here, but this here covers that gap. So then the range is all real numbers as well. Where is the graph continuous? The graph is continuous from negative infinity to this discontinuity at 1, and then from 1 on to infinity. Is there any discontinuity? The answer is yes, because notice it stops here at 1 and then jumps down. So this is a jump discontinuity. At x equals 1. Where is the graph increasing, decreasing, or constant? Well, it is not constant because there's no flat part. It increases from negative infinity to this point here, which is at negative 3. Then it decreases until you get to x equals 1. And then at x equals 1, it's still decreasing until you get to 5. And then from 5 on, it increases again. Is the graph bounded? The answer to that question is no, because it's not bounded above, because you have an arrow here that means it goes on forever, so it's not bounded above. And it's not bounded below because of this arrow right here. So therefore, the entire graph is not bounded. Any local or absolute extrema? Well, there's going to be a local maximum here. At y equals 5. Sorry, of negative 5. Sorry, positive 5. Positive 5 at x equals negative 3. There's also a local minimum down there at the bottom of negative 10 at x equals 5. There's no absolute extrema because the graph is not bounded in either direction, because this arrow means it goes down forever there and it goes up forever here, so there's no absolute extrema. All right, hope you enjoyed the video, and I will see you guys in class on Monday. Have a good weekend, and I will see you later.